Okay, in this video we're going to be solving quadratic inequalities algebraically. So in the last lesson we talked about how to solve an inequality like this graphically when you had your graphing calculator with you. In this video we're just going to talk about how to do it when you don't have a graphing calculator. So how to solve this inequality when you may not know, or when you don't have a graphing calculator to tell you what the graph looks like. So the way that we're going to solve this inequality, the first couple steps are very similar to how to solve an inequality when you do have a graphing calculator. So with this one, similarly, I want everything to be on one side, 0 on the other, so I don't actually have to do anything to get that to happen with this one. And from here, similarly to yesterday, we're going to factor this out if we can. So off to the side, I'm going to do snowflake. I'm multiplying to a negative 10, adding to a negative 3, and my coefficient of x squared is just 1. From here, I want to think about two numbers that will multiply to a negative 10 and add to a negative 3. Those two values are going to be negative 5 and a positive 2. So my two roots are going to be x minus 5 and x plus 2 is greater than or equal to 0. So now at this point, once I factor this out, if I had my graphing calculator in front of me, I would graph it. But if I'm solving this just purely algebraically, so without a graphing calculator, the main idea that I'm going to use is I'm going to think graphically. So I want to think, what would the graph of this function look like? And so the first thing, there are a couple of questions that you're going to ask yourself. The first question you're going to ask yourself is, what is the shape of this graph? And so in this case, we're only going to be solving quadratic inequalities algebraically, so never anything that's not a quadratic, which means that my largest power is x squared. Well, when my largest power is x squared, I always have a parabola. So whether that's an upward-facing parabola or a downward-facing parabola, I'm not sure, but it's going to look like a parabola. The next question that I need to ask myself is, well, since I know I have a parabola, does my parabola face up or does it face down? Your parabola is going to face up when you've got a positive x squared, so this could be x squared, or it could be 2x squared, it could be 100x squared. You've got some positive number in front of your x squared. The parabola is going to face down when your coefficient in front of x squared is negative. So if I've got a negative x squared, or a negative 4x squared, or a negative 50x squared. Any of these would result in a downward-facing parabola. It does not matter what the rest of my function has. To figure out if my function faces up or faces down, I just look at the x squared. So this could be x squared plus 3x minus 500, and it would still be facing up because the x squared value is positive. The last question you're going to ask yourself is, does my parabola have real solutions? Or does my parabola only have imaginary solutions? So if you're able to factor out your parabola, then this means that this function, x squared minus 3x minus 10, has a real solution. If you are able to do the quadratic formula and find solutions, then you have real solutions. However, if you go through and use the quadratic formula and you end up only with imaginary solutions, so with a negative in front of my, or negative inside of my square root sign, then your graph is not going to have any x-intercepts. That's when it's going to be either hovering above the x-axis facing up, or down below the x-axis facing down. So that graph is never going to cross this x-axis if it only has imaginary solutions. So let's take a look at this equation again, what type of equation or what type of graph am I going to be looking at with this original f of x, x squared minus 3x minus 10? Great, you should have said that I'm going to have some type of parabola. Now you want to ask yourself, is the parabola going to face up or down? Well, in this case, my x squared value is positive, so I know that my parabola is going to be facing up. The last question that I want to ask myself is the real solutions. When does y equal 0? Or when does my f of x equal 0? And to answer that, well, I factored this out. So I want to know, when is x minus 5 times x plus 2 equal to 0? So I set each of these pieces equal to 0. X minus 5 equals 0. X plus 2 equals 0. So I get the values x equals 5 and x equals negative 2. Those are my real solutions, or where it's going to cross my x-axis. Now that we've answered that, so I know I've got a parabola, it's facing up, and it's got two solutions, I can go ahead and sketch what my graph is going to look like. So at positive 5, 1, 2, 3, 4, 5, I have a solution, and at negative 2, I have a solution. And I'm just going to sketch the rest of my parabola. Through those points, it's facing up. It doesn't matter how accurate this is, just as long as it has your solutions, you know it's a parabola, and you know whether it's facing up or down. Now that I have a sketch of my graph, I'm going to consider, well, where is this function? Where is my original function greater than or equal to 0? So this is asking the same question as the last 2 days. Where is my y, or where are my y values greater than 0? So I'm going to sketch the top half of my graph. Down below my graph, I'm going to draw my number line. And I've got my two critical values on it, so negative 2 and a positive 5. Are my solutions in between negative 2 and 5? Or are they outside of 5 and negative 2? Well, if you test some values at 0, so at x equals 0, which is in between negative 2 and 5, my graph is down here. This point is not in the shaded section, so 0 would not be considered a solution. Same thing with 1, same thing with 2, 3, and 4. They're all not in the shaded section. So my solutions actually are not in between 2 and 5. Instead, they're outside. So if I look at 4, well, that's in the shaded section. If I look at negative 3, again in the shaded section. So my solutions are going to the right of 5 and to the left of 2. Since my equation can equal 0, I'm going to put a closed circle at negative 2 and a closed circle at 5. What would my interval notation for this inequality look like? If I start from the left, my smallest values are negative infinity, and they go to a negative 2. Negative 2 gets a bracket because it is included. Then there's this break where I don't have any solutions. I'm going to put a U where I have that break. My solutions start up again at 5. 5 gets a bracket. And I'm going to infinity. Infinity gets a parentheses. And go through these two problems that are for you. One more practice problem, and then with a slightly different scenario, and then you'll have some practice to do for yourself. So I'm going to start off to solve this problem. So 2x squared plus 4x minus 3. If I go to try to factor this out, So I'm finding two numbers that multiply to a -6 that add to 4. Unfortunately, there are going to be no two numbers that do that. So I cannot use Snowflake. In this case, I've got to use the quadratic formula. So x equals -b, which is 4, plus or minus the square root of b squared, minus 4 times a, which is 2, times c, which is a -3, all over 2a, which is 2. I'm going to go ahead and simplify that, pause, and see what you end up with. You should get x equals -4 plus or minus the square root of 16 minus 4 times 2 is going to give me 8 times a -3 all over 4. This is going to give me x equals -4 plus or minus the square root of 16 plus, so a negative times a negative gives me a positive, 24 all over 4. To leave me with x equals -4 plus or minus the square root of 40 all over 4. And I can leave, for these problems, you can leave this like this. You're going to have two different roots. So x equals -4 plus root 40 over 4, and x equals -4 minus root 40 over 4. Take a moment and identify, if you were to put these on a number line, which is going to be the smaller number, the one that's more to the left. Okay, when I've got an option between these two, so I've got a negative number plus some number, I don't know if this is going to be positive, but I do know that this is getting me further away from 0. It's getting me more towards the positive. So this root is going to be my more positive root, -4 plus root 40 over 4. Versus with this one, I've got a negative number, and I'm subtracting another number from it. So if I've got a negative minus any negative, I'm moving further away from 0. I'm getting more, or I'm getting smaller. So my smaller root is going to be -4 minus root 40 over 4. So now I've got my solutions. I want to think back to this original function. What will the graph look like? Well, I know I have a parabola. I also know that it's facing up because of this positive 2. And I know that it has two real roots. So I'm going to go ahead and just draw a sketch. Here's my upward facing parabola with two real roots. So the smaller root, the one more to the left, is going to be this -4 minus root 40 over 4. And my larger root is going to be this -4 plus root 40 over 4. So in my original inequality, I'm looking for where this is less than 0. Do I shade up on my graph, or do I shade down? Right, I should shade down since I'm looking for where y is less than 0. Okay, so on a number line right below, I'm going to put my two critical values, so -4 minus root 40 over 4, and a positive -4 plus root 40 over 4. Sorry that you can see that. Now I'm going to ask myself, well, are my solutions in between these two values, or are they on the outside? What do you think? Okay, well, if I test some values at x equals 0, which is in between, I'm going to say it's in between these two values. I don't really know. I've got a solution that's in my shaded section. So I've got a solution in between these two values, which means that I'm going to shade in between them, even if I'm not really sure what those two values are. What type of circle goes at those two values? Great. An open circle is going to go at these two. So my inequality or my interval notation will look like what? Interval notation should start with parentheses, then my first root, so -4 minus root 40 over 4. How about my second root? -4 plus root 40 over 4. And I'll end with parentheses. Solve these three for you.